Hi guys, in this video, in this lecture, you are going to learn and you are going to see few concepts regarding chapter 1, chemical reactions and equations. So this is first chapter in your science, and here I'll be explaining concepts which are there in your textbook. Just we'll see brief, not a lengthy one. I cannot go in deep, just I'll explain just concepts. Okay, first let us start with the chapter name chemical reactions and equations. In this chapter, what main thing you are going to learn in the sense in grade 7 or in grade 8 you might have learnt about difference between physical change and chemical change. While coming to physical change, change which is temporary, and while coming to chemical change, change which is permanent. And again, physical change, changes which can be reversible, while coming to chemical change, changes which are not reversible. And in your grade 10, we don't have any concepts related to physical change. No need to learn anything, but we have to concentrate on chemical change. You see, guys, try to understand this flowchart. Whenever you are seeing or whenever you are saying there is some chemical change, you can express you can express that chemical change in form of, or you can say that chemical change in form of reaction. For example, if you take some amount of curd and if you put it in milk, after some hours, that milk will become curd. So you can observe some chemical change and you can observe that chemical change in form of reaction. If you pass electricity through water, you can observe some gas bubbles will be coming out. So you can observe some chemical change, you can express that chemical change in form of reaction. And if you can explain or if you can express, if you can write that reaction in form of equation, then that is known as chemical equation. Try to understand that flow chart. So whenever you are observing some chemical change, you can express that, you can explain that in form of reaction, and that reactions in short form you can write in form of equations, and those equations which are representing that chemical change known as chemical equations. So here you can observe the chapter name chemical reactions and equations. So in this chapter you are going to learn about reactions, different types of reactions you are going to see, and how to represent that chemical reaction in form of equations, balancing equations, that and all we are going to see here. You see this first concept, the process in which new substance with new properties are formed from one or more substances is called chemical reaction. If they ask you what is meant by chemical reaction, you take one substance and add that substance to another substance, you will get one new substance. That type of reaction is known as chemical reaction, and there are few properties for chemical reaction. You cannot say directly that one is chemical reaction. There are few observations that we are going to discuss. You see, try to understand this one. If any substance, maybe solid, liquid, gas, is reacting with another substance, maybe solid, liquid, gas, you can find, or you can get one new substance. That new substance also can be in form of solid, liquid, or gas. Such type of reactions known as chemical reaction. Here, the substances which take part in chemical reaction are called reactants. Here you see this, these two are known as reactants because both are reacting with each other, both are combining with each other. And here you can get one new substance. That new substance, substances which are formed after chemical reaction, I mean after reaction, that known as product. So this arrow mark you have to pronounce like gives rise to, this is before reaction, This is after reaction. Before reaction, what are the chemicals, what are the substance are participating, which are taking part in chemical reaction known as reactants, and substance which are formed after reaction is known as product. Try to understand this. So from this what we can say, reactant plus reactant, guys, you can get you can take minimum one, you can take maximum many. Reactant plus reactant gives rise to product, or sometimes you can get two or more products also. So before reaction you have to call it as reactant, after reaction you have to call it as product. That is the one thing you have to remember. Okay, first let us try to understand this, and then let us see examples. You see, guys, when you have to say chemical reaction is taking place, there should be change in state. So, what are the products you are getting? That state should be different from the reactants. Not always, but maximum. Change in color. So, what are the colors you are getting for these products that should be different from these reactants? This is important. Change in temperature. So you can observe there will be rising in temperature, sometimes falling in temperature also. We can discuss that one in this lecture itself. Exothermic, endothermic, that we'll see. Change in temperature. So after getting new products, sometimes you can get heat energy also. This one, evolution of gas. While reaction is taking place, product, sometimes you can get few gases: hydrogen gas, oxygen gas, carbon dioxide gas, nitrogen gas, etc., but not helium, neon, argon, because these are inert gases. Okay, next, another main important thing, always new substance is formed. That is most important point. So this is the first point you have to consider. Actually, when reactants which are reacting with each other, and when products are formed, these products are always new substances. For example, you take when carbon is reacting with oxygen, we can get carbon dioxide. Guys, we didn't balance this one, we'll balance, don't worry. So I'll tell you how to balance this one. O2, so it is O2, we can leave it. C plus O2 gives rise to CO2. You see, guys, carbon and oxygen, when both are mixing together, we are getting carbon dioxide gas. It is new substance, like that. Next, here you see, while coming to example, digestion of food. When food is digested, again the digested food can, you see, what are the examples we are taking or chemical reactions. What is meant by chemical reactions are simply to what is meant by chemical change, changes which are irreversible. Irreversible. Irreversible means which cannot be retreated back. You cannot take it back. Respiration. So you are inhaling oxygen and exhaling carbon dioxide. Again, oxygen cannot be exhaled out. Rusting of iron. If you take an iron and if you keep it outside, when that iron is exposed to sunlight, water, some gases, automatically reddish brown layer is formed on this one known as rust. So which is chemical change. Burning of magnesium ribbon. You can go to your laboratory or you can observe Diwali days. On Diwali, you will be taking some ribbons. So if you see that magnesium ribbon and if you heat that magnesium ribbon in presence of oxygen, automatically that magnesium ribbon will glow with white dazzling flame. Again, that powder cannot be made into magnesium ribbon. Formation of curd. Take milk, add some amount of curd to it, that milk will become curd. Again, you cannot reverse that curd to milk. So what are the examples we have taken? Digestion of food, respiration, rusting of iron, burning of magnesium, formation of food. These all are chemical changes. So whenever you observe chemical change, whenever you observe chemical change, that chemical change is nothing but chemical reaction. So for all chemical reactions, you can represent chemical equation. That is a simple flowchart you have to understand. You see, whenever you see chemical change, you can say in form of reaction, that all reactions, reactions, you can write in form of equations. After this, you see ways of representing chemical reaction. So we are taking one example. First, you see guys, it is very easy for us to say paragraph. You see what I can say, if you take zinc and add that zinc in sulfuric, take one test tube, add few drops of sulfuric acid in the test tube, take 1 or 2 granules of zinc and add that zinc in the test tube. After some time, after few seconds, you can observe some gases will be coming out from the test tube. That gas is hydrogen gas, and you can observe one transparent salt will be present in the test tube, that is zinc sulfate. You see, to explain that one, nearly I am saying 4 to 5 lines, isn't it? 4 to 5 lines. And if I ask you to write those 4 to 5 lines, it will become one big paragraph. Now, every time it is not possible for us to write this big paragraph. Instead of that, what we can do is, this paragraph can be made it short by means of word equation. We can shorten that paragraph, that 4 to 5 lines in single line, that is known as word equation. If you can observe, what are the concepts I have explained here? Just zinc plus sulfuric acid, this arrow mark gives rise to zinc sulfate plus hydrogen. So instead of writing 4 to 5 lines, take one test tube, add 2 to 3 drops of sulfuric acid, add 2 to 3 granules of zinc. You can observe one gas is produced out, that is hydrogen gas, and transparent liquid is settled down in the test tube, that is zinc sulfate. Instead of 4 to 5 lines, you can say zinc plus. What is the meaning of this plus? You are adding. For what you are adding? To sulfuric acid. Okay, if you are adding zinc to sulfuric acid, what is happening? Reaction is taking place. That arrow mark is representing the reaction. Okay, what is happening after reaction? The transparent liquid, that is zinc sulfate, at the same time plus you are getting one more extra product, that is hydrogen gas. So instead of writing 4 to 5 lines, you can sum it up in single line. That's it. Again, you see, it is not always possible for us to write this word equation, because ZINC zinc plus SULPHURAC sulfuric acid, it will be somewhat lengthy. Again, you can shorten this word equation also by means of chemical reaction or chemical equation. So paragraph, you can make it into short by means of word equation. Word equation, you can make it into short by means of chemical equation. How? Instead of ZN, you can use symbols. At the same time, you can use chemical formulas. Try to understand symbols and formulas, which already have learned in your grade 9, chapter 3 and chapter 4. Chapter 3, atoms and molecules, you have learned, right? Now, symbols and formulas. You see, for zinc, you can use symbol Zn plus. Sulfuric acid symbol is H2SO4, gives rise to zinc sulfate, ZnSO4 plus hydrogen gas H2. Like that, you have to shorten this one. And remember, in your grade 10, chapter 1, chapter 2, chapter 3, try to represent chemical equations only. No need to represent this word equation. No need to write this paragraph. So what is chemical equation? A chemical equation can be represented by chemical equation. So this reaction, chemical reaction, can be represented by chemical equation. It is shortcut. It involves uses of symbols of elements or chemical formula. I told you. You can write symbols or chemical formulas of reactants and products. So before reaction, known as reactant. So here you can observe this is reactant. After reaction, known as product, this one. Mention physical state. So you can mention states also, that we will see there. You can, if it is solid, mention as S. If it is liquid, mention as L. If it is gas, mention as G, or you can mention top arrow mark for the gas. And if it is any solution, you can mention it as AQ, stands for aqueous. Nothing but if salt is dissolved in water, aqueous solution. Base is dissolved in water, aqueous solution. Acid is dissolved in water, aqueous solution, like that. And if there is any precipitation, you can mention down arrow mark, that and all we will see. Now you see this zinc. How to represent zinc? It is solid. Yes. H2SO4, liquid or AQ, ZnSO4, AQ, gas, like this. We'll see everything. The necessary conditions such as temperature, pressure, or any catalyst. So this catalyst, that and all we'll see in third chapter, should be written on arrow between reactant and product. So temperature. So if you want a temperature, if you want to represent, you can represent with this delta. Delta stands for heat energy. Pressure. So I have to mention with ATM, atmospheric pressure. Catalyst, maybe zinc catalyst or AgNO3, silver nitrate catalyst, whatever it may be, you can represent on arrow. So for example, you are drawing this arrow. Arrow means gives rise to. On this, if you want to represent heat, like this. If you want to represent pressure, ATP or ATM, whatever it may be. ATP you can represent atmospheric pressure. ATM you can represent, both are same. Or on this. So in chapter 4, you can observe potassium permanganate, that and all you will get. KMNO3. Like that you have to represent on arrow mark only. Between reactant product. Here arrow mark is there, right? Between reactant product, on this you have to represent. Example, so same, magnesium is burnt in air to form magnesium oxide. So you can see this magnesium, if it is reacting with oxygen, it is giving magnesium oxide. Here magnesium and oxygen both are reactants. Magnesium oxide is product. Now main thing is balancing chemical equation. Guys, I don't want to waste my time regarding this balancing equation, because already I have made a video regarding this balancing equation, and I'll give you link regarding this, that one. And in that link, if you open, you can get one video, just something around 50 minutes or 1 hour video. If you see comments, if you see comment, I have posted timeline in that comment. Okay, so you can observe the timeline. Beside the timeline, I have given what are the concepts you will be getting at the particular time. So you can observe that balancing chemical equation, so easily you can understand it. So same, stepwise I have given, I have explained hit and trial method. This method is known as hit and trial. You can watch that video to understand. Okay, let us jump into this main concept. Types of chemical reactions. So you see guys, we have been talking about chemical reactions, chemical equations, and there are different types. So let us try to understand that chemical equations types. So in biology, if you might have observed, there are different types of animals, different species are there, and if it is not possible for us to learn about all species. So what you did, those biologists, they have divided all species into different categories, like kingdoms, animal kingdom, like that. Same like that in chemistry, if you observe, you can find some hundreds of chemical reactions, hundreds of chemical equations, thousands of chemical equations you can get, and it is not possible for you to learn about each and every reaction. So that they have divided all these chemical reactions into 4 categories. Number 1, combination reaction. In the name itself you can find the reaction in which 2 or more reactants combine to form single product. You see, there might be one reactant plus another reactant, both are come 2 or more, maybe three combining together to form only single product. Try to understand. So you can understand this one, like if A is one reactant combining with B, A and B combining together to form one single product known as AB. Single product known as AB. Example, you see guys, C stands for carbon, plus here this one O2 stands for oxygen. A is just comparing carbon nothing but A, oxygen nothing but B, gives us to what we have to get guys here, AB means CO2, like that, carbon dioxide. Another one, H2, hydrogen, if it is combining with oxygen, H2O2 gives rise to water molecule, that is H2O. And if you balance, you will get this one. I told you, right? You can watch that video to understand that balancing. So you can watch that video and then you can come back to this lecture. Hydrogen plus oxygen. Hydrogen is one reactant, oxygen is another reactant. Both are combining together to form only one product, that is water molecule. And you see guys, again you can take this example, CaO, calcium oxide plus H2O, water. Calcium oxide is also known as quicklime. If you take quicklime and if you add that quicklime powder in water, you can get, you see, CaO is one reactant. You can consider this one as A. H2O is another reactant. Consider it as B. A plus B gives rise to AB, right? Both will combine together and it will form Ca. How to pronounce this? CaOH taken twice. This also I've explained in that video, how to pronounce all these and how to count everything. So calcium oxide reacting with water to form calcium hydroxide known as slaked lime. So that is about combination reaction, and here we have to learn about exothermic reaction. So what, there are two types of reactions, exothermic and endothermic. Exothermic means reaction in which heat is released along with the formation of product. This is product, along with the product heat energy is also released. So you can see this example, burning of natural gas. You see CH4. CH4 means it is methane. When CH4 is reacting with oxygen, it is giving few products like carbon dioxide plus water is another product. At the same time, heat energy is also released. So if heat energy is released out, such type of reactions are known as exothermic. So what is exothermic? Reactions in which heat is released along with the products. You can take another example, respiration. Our body will be warm. We are warm blooded animals. Why? Because you see C6H12O6 plus glucose, right? C6H12O6 plus O2, oxygen we are inhaling, and we have some glucose in our body, and we are exhaling what? We are exhaling carbon dioxide. At the same time, water is coming out from our body in form of water, sweat, urine, etc. At the same time, some energy is released, some heat energy is released. We have some body temperature. Those are exothermic reactions. They might ask you an examination, define exothermic reaction or what is meant by exothermic reaction, and give example. In these two, you can give any one example. Yes, we have seen combination reaction, that is first type. Next one, decomposition. In the name itself, we have the reaction in which single compound splits into two or more simple substances. Here we can observe A, which is splitting into B plus C, or simply to say AB splitting into A plus B. You see guys, if you take one small chalk piece, if you want to break the chalk piece into two to three pieces, what you have to do guys? You have to apply some force to that one, right? Without applying force, can you break the chalk piece? No, it is not at all possible for us to break it. Now that force, here we have to understand there are three types of forces we have to understand in this chapter. First one, thermal. Thermal means heat is one force. Electrolytic means electricity is another type of force. And last one, photolytic means sunlight is another type of force. Three types of forces we are using in chemical reactions and equations to split that reactant. You see, thermal, when decomposition is carried out by heating. For example, you take FeSO4, ferrous sulfate. If you take that ferrous sulfate salt, which will be in green color, if you want to split that ferrous sulfate into 2 to 3 products, what you have to do? Guys, if you remember, here I told you one thing. On this arrow mark, you have to represent maybe heat, maybe light, maybe atmospheric pressure, whatever it may be. Here you can observe clearly FeSO4, ferrous sulfate gives rise to, here what force we are giving to that one? Heat. If you heat that ferrous sulfate in test tube, you can get ferric oxide, sulfur dioxide, sulfur trioxide, SO2, SO3. Here only one reactant, but products, first product, second product, third product. Simply to say how to understand this one, if ferrous sulfate is ABC, ABC is splitting into A plus B plus C. Simple. Now it is CaCO3. What is CaCO3? Calcium carbonate, limestone. In chalk pieces, we can use that one, calcium carbonate. If you take that calcium carbonate and if you heat it, what are the products you are getting? CaO, calcium oxide, which is quicklime, and carbon dioxide. So this you can compare with AB splitting into A plus B. This AB is calcium carbonate. If you heat, you have to write on this arrow mark, guys. If you heat this calcium carbonate, you are getting calcium oxide plus carbon dioxide. You have to balance whatever equations you are writing. You have to balance all these equations. Next, electrolytic decomposition. What is electrolytic decomposition? Second type of force, that is electricity. You take water, H2O. So if you take water and if you pass electricity, simply to say, if you pass current or if you pass electric current, you have to represent that on arrow mark. Here you can observe, you have to represent on arrow mark. If you pass electricity through water, you can observe few bubbles. Those are hydrogen gas bubbles and oxygen gas bubbles. Small diagram which is there in your textbook. Take one jar, add some amount of water, insert two electrodes, connect those two electrodes to small battery of capacity 2 volt, 6 volt, 10 volt, 12 volt, etc. And if you take the test tube and if you insert those test tubes near the electrodes, you can observe few bubbles will be coming out. Here's few in previous year question they have asked. If you take those two test tubes, in one test tube level of water will be high, in another test tube level of water will be least. I mean, this gap here, this gap, or you can call this one as area. Here it is small area, here it is big area. What is the indication? You see, what is chemical formula of water? It is H2O. What is H2O meaning? Two parts of hydrogen and one part of oxygen. So if you observe, this is one part, this is two parts. Simply to say, where you can find more gap, more area, this is hydrogen gas, and less gap, it is oxygen gas. You can observe, this one is oxygen, this one is hydrogen. Next, what is photolytic decomposition? You have to split the reactant into products by using one force. That force is sunlight. When decomposition is carried out in presence of sunlight, known as decomposition, you can see this AgCl, silver chloride, AgBr, silver bromide. When silver chloride, if you keep that silver chloride powder outside in presence of sunlight, automatically that silver chloride will be splitting into silver and chlorine. Same, silver bromide, silver and bromide. Here above reaction, which one? Silver bromide, silver plus bromine splitting up, which is used in black and white photography, guys. Most important thing, they have asked 2 to 3 times in your board examination, previous board papers, you can observe. Yes, we have discussed about exothermic. Now we have to learn about endothermic. What is endothermic? So first of all, you have to understand what is exothermic, and here we can observe what is endothermic. Exothermic, when reaction is taking place, it will produce some heat energy, right? Heat energy is given out. Endothermic means heat energy should be given for what? For chemical reaction. Consider there are some reactants and it will not produce product. If you give heat energy to the reactant, then only products are formed. So if heat energy is generated, exothermic. If heat energy is given, endothermic. Okay, heat energy is liberated in exothermic. In endothermic, heat energy is given to that one, right? So the reaction requires, which requires heat energy, energy in form of heat, light, electricity to break the reactant is called endothermic. So these all you can take it as endothermic reaction. Next, displacement. Till now we have seen two. First one, combination. What is combination? If A plus B, or simply to say, if two reactants are combining together, it will form one product called AB. Second, we have seen decomposition, that AB reactant will be splitting in form of A plus B products. Right. Now displacement. What is displacement? It is quite simple. Try to understand this. Consider we have A, one metal. So this displacement you can observe in metal and salt combination, guys. Metal plus we have one XY salt. Consider we have one metal A and salt XY. What will happen if metal is given to salt? When metal is combining with salt, automatically you see, you know how salt is produced. Salt will have two parts. First part is metal part, guys. Salt will have two parts. Consider XY is salt, X is metal, and Y is compound. Compound like sulfate, nitrate, chloride, etc. Okay. Now, if metal is combining with salt, you can observe this metal from salt will displace out. I mean, X you can get here. And this A will be combining with Y, you will get AY. So try to understand. Ferrum, iron is metal. Copper sulfate. In copper sulfate, I told you salt will have two parts. CuSO4, two parts. This copper is metal. Cu. This SO4, sulfate is compound part. Copper sulfate, copper nitrate, copper chloride, like that. So now what will happen? This copper will be displacing out. Here you can observe copper is coming out. At the same time, ferrum is combining with this sulfate and forming ferrous sulfate. You can take another example also. Fe, ferrum. Okay, not only Fe. You can take some other metal, magnesium, Mg plus CuSO4. Now easily you can analyze. So when magnesium is metal combining with a salt, salt will be, this metal from the salt will be displaced. Copper you can get it here, plus this magnesium will be combining with sulfate, you can get MgSO4 magnesium sulfate. Simple. That is displacement. So zinc plus copper sulfate gives us to zinc sulfate plus copper. Always you can observe displacement reactions in metal plus salt combination. Next, double displacement, simple. It is single displacement. If there are two displacements, you can find double displacement. Always double displacements you can find in salts. The one salt is combining with the second salt. First salt is combining with the second salt. Of course, you can get salt plus salt. Don't get confused. You see, sodium sulfate is one salt, sodium sulfate, reacting with barium chloride is another salt. Now what will happen, guys? From sodium sulfate, sodium will displace. From barium chloride, barium will displace. That barium will go and combine with sulfate, and sodium will go and combine with chloride. Sodium chloride, you can find sodium chloride here. Barium is combining with sulfate, barium sulfate, you can find it here. So like that, you know what is salt. I can give you another link where I have explained about how to identify acids, bases and salts. That also another video I have made it. Two links I will give you. First link regarding balancing chemical reaction. Second link regarding how to identify acids, bases and salts. There clearly I have explained about, if you take salt, how salt is formed. What are the two parts of salt? How come this metal is reacting with this compound? That and all I have explained in that. You can get clear information. So at last we came to last topic, that is oxidation and reduction, such that we can wind it out. So oxidation and reduction. What is meant by oxidation? You see the addition of oxygen to substance. Whenever you see chemical reaction in which oxygens are added to the substances, for example, copper plus oxygen. You see, copper plus oxygen. Oxygen is given to this copper. Now what you can get? Copper oxide, cupric oxide. Now oxygen is added to, simply you can say, right, oxygen is added to copper. Now that addition of oxygen to substance is known as oxidation. Now you can say copper got oxidized. Are you getting point? Copper got oxidized. Here you can see carbon plus oxygen, carbon dioxide. Now carbon got oxidized. Now you see, not only addition of oxygen, guys, removal of hydrogen is also, removal of hydrogen is also oxidation. Now, you can take another example. Copper oxide plus hydrogen. Hydrogen. Now, oxygen is added to hydrogen. Oxygen is added to hydrogen. So that only you are getting H2O. Now we can say hydrogen got oxidized. Hydrogen got oxidized. But if you observe this copper oxide, here oxygen got removed. Now you see, try to understand reduction. Oxidation means addition of oxygen or removal of hydrogen. What is reduction? Removal of oxygen or addition of hydrogen. You can take this example. Copper oxide plus hydrogen gives rise to copper plus H2O. Now what is happening? Oxygen is given to hydrogen and H2O. Simply to say hydrogen got oxidized. But copper oxide, if you observe, oxygen got removed, right? So if oxygen is removed, we can say this copper got reduced. Okay, so oxidation means if anything is oxidized is oxidation, if anything is reduced, known as reduction. In this reaction, copper oxide is reduced to Cu, means CuO is becoming Cu. So that only you are mentioning here one arrow mark, CuO is becoming Cu, reduced or reduction, you can write. Hydrogen got H2O, hydrogen is becoming H2O, you can mention oxidation, like that. So Cu and H2 is oxidized to H2O. So oxidation and reduction taking place together. Now in a reaction, if you find oxidation and reduction both, it is known as redox. It is known as redox reaction. Okay, another beautiful example. H2 plus O2 gives rise to H2O if I write 2H2O, 2H2O if I balance. Now, is that oxidation or reduction if I ask you? You see, hydrogen is getting oxidized, means oxidation you can find. Oxygen, for oxygen, hydrogen is added. So if you add hydrogen, it is reduction. So oxygen got reduced, simply to say reduction. So this equation you can say it as redox. What is meant by redox? Combination of reduction at the same time oxidation, known as redox. Now, effects of oxidation in daily life. Last topic, corrosion rancidity. What is corrosion? If you take any metal, if you expose that metal to oxygen, air, moisture, water molecules in atmosphere, automatically you can find rust. One layer is formed on the metal, that layer is known as rust. When metal is exposed to substances such as moisture, acid, maybe oxygen, for some time a layer of hydrated oxide is formed, which weakens the metal strength. Hence that metal is said to be corrode. That iron got corroded. So you can find first question in your textbook, why it is advised to rub that magnesium ribbon with sandpaper before burning. Because when magnesium is exposed to atmosphere, automatically layer is formed. If you use sandpaper such that you can remove that corroded layer, such that it can catch fire easily. If it is not, it will not catch fire. Rusting of iron, black coating on silver, green coating on copper are examples of corrosion. How can we how can we prevent that metals? By galvanization, application of zinc metal on iron, electroplating, painting, application of grease, oil, etc. Which again you will get it in third chapter, metals and non-metals. Rancidity. What is rancidity? It is very simple. If you expose any oil items, fat items, food items to air, oxidation of fat oil items, when exposed to air, there will be some bad smell, bad taste, which is nothing but rancidity. Okay, so that how to prevent the rancidity? By adding antioxidants, replacing air with nitrogen. You can observe chips packet, you can see Lay's, Kurkure. If you take those packets, it is filled with one gas. If you open, less amount of chips will be present in the very big packet. That is filled with nitrogen, because to prevent from oxidation. So when food items exposed to oxygen, it will become rancid. Keeping food in airtight containers. So you can pack that in a very good airtight container such that it will not become rancid. At the same time, refrigeration. We have refrigerators. If you keep food items in refrigerators, it will not become rancid. So that's it about this chapter. Very small and easy chapter. And here balancing, it is main heart of the chapter. I'll give you a link. You can observe that one such that I have explained step by step method how to balance chemical equation, and we have many concepts in that, how to count, how to balance, and there are a lot of examples. I have given 20 to 30 examples. You can watch that one. And all these concepts, once again, you read textbook such that you can understand this chapter very well. So that's it regarding this chapter 1.